people, come on. Eric, hello Eric, hello Ryan, how are you today?
Good.
Okay, so we talk about the binary tree. Can you give me an example about the binary tree, please?
Okay.
Yes.
Oh, where was it? Oh yeah, here it is. Oh yes. Do.
Yeah.
Open 8. I'll put 0 plus 1. Equal 1. 2.
That's okay, come on.
Oh, and I'll put 8. 8, 2, 6, 10, 1. And I'll put 1 here.
Okay, so good. So basically,
8 to 8.
so basically, how many root? Which one is the root?
8.
8. And which one are the leaf nodes?
6, 1, 1.
Okay, that's good. What is binary mean?
2.
So that means that each node could have at most 2 kids, right?
Mm.
And each node could have at most 1 parent, except the root, which doesn't have parents. Okay? Does it make sense? Yeah? And for the binary tree, it does not have cycles, yeah? It does not have cycles. Alright? Does it make sense? Okay. So for these binary trees, how many ways can we traverse the binary trees?
Breakfast search, deficit search.
Breadth search, depth search. Okay. So if it's breadth search, what's the order? Can you give me the order?
8, 0, 2, 6, 1, 1.
Well done. So basically, it's level by level, yeah. And what's the depth search order?
8, 0, 6, 1, 2, 1.
Well done. Yeah, that's good. So look, if we look at each levels, we sum it up. Sum the nodes in each level. So this one is level 0 with sum 8. This one is level 1 with 0, 2. And this one is number 8 with 0, 8. Yeah, number 3. Okay, let's make it another one. So let's say is 9. Okay, so
That's 3.
okay, so 9. Okay, so our task is given a binary tree. We want to find out which level has the most largest sum, which is 9, right? Okay, so if it has more than one level has the same sum, we can just return any of it. Okay, does it make sense?
Yeah.
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 What you doing? What you doing? What's that?
Trophy.
Trophy. Okay. Okay. Trophy. Okay. Yeah. Trophy. Yes. Number 1, 3. Yeah. Okay. So, how are we doing this?
Breakfast search.
Breadth search is easier. Yeah. You can also use the depth search, but we can talk about it tomorrow.
Yeah,
Okay.
it'll be more harder.
Yeah, it'll be less intuitive. You know, because we are calculating the sum. We need to get the maximum sum, right, for each level. So obviously it's quite straightforward to use the breadth search, right? Alright?
Yeah.
Because it traverses the tree level by level. Okay, so what kind of data structure are we using to implement the breadth search?
Q.
Q. Okay, let's do it.
Certainly.
BFS root. What's missing? If root is none, so if root is none, which is a special case of binary tree, which we can...
None. No, 0.
Yeah, we can define it. We can argue it's 0 or nothing because we are retaining the level, which it doesn't have any levels of the nothing, right? So we return none, which is which is better, yeah? Because empty tree does not have any level. Remember, the root, and it's at level 0, okay?
It's always Owen.
Okay, so look,
Yeah, I said that.
Q equals, what kind of data structure are we using in Python?
Breakfast search.
Root, we initialize with the root. What's this? What should we put here? What kind of data structure are we implementing? Are we using as the Q?
DQ.
DQ, yes, well done, DQ. So DQ, what's DQ mean?
Double-ended Q.
Okay, well done. So for the breadth search, we already initialized the queue with the root, and how do we check? How do we repeat one layer's element in the queue? So we use the while loop, right? Yeah. So we can do this while length q bigger than 0, right? And
Yeah.
what's missing?
Column.
Okay, so all these can be replaced by just YQ, which is simpler, yeah? It means that Y still there's an element in the Q. Got it?
Yeah.
Yeah? Okay. YQ, then normally we DQ one element one by one, right?
Mm-hmm.
But now for this, actually every time we want to DQ, all the elements in the Q is pointing to the same level. It's the same level, right? For example, look, the first one is A, right? Now it's A. A is belong to the level 0, right? We know it's level 0, right?
Mm-hmm.
If we take it out, we push all the kids of A is 0 and 2. And the next time we want to DQ, we know all the Q's in here will be the same level, right? Yeah? That will be 0 and 2 will be level 1. If I take them out, and I push all the kids of 0 and 1, it will be 6, 1, 2. And next time I take it out, I know 6, 1, 2 is the same level. Does it make sense?
Yeah.
Okay, that's good. So in order to do this, we need to have a value to store the level. Yeah, we call it level equals 0 at the beginning, right? And then now, current nodes. Let's say SC equals length Q. What does it mean? It means that we want to know how many nodes in the next level. Am I right?
Yeah.
Okay, so now for dash or I in range SZ column, yeah? So now we need to do this DQ how many times? We need to do this DQ how many times?
0.
SZ time, right?
As many times as you would.
Okay, now look, I am running out of space. So for in ranges SC, this underscore, yeah, means that we don't want to use any variable. It doesn't matter. You can put the I, J, K, or we are not using this variable here. So that's why we just put a dash. It means we don't care, right? Does it make sense? Yeah?
Yeah.
And then repeat SZ times.
SZ.
Okay, so now we also need a variable to sum up the value, right? Let's call it x, okay? X equals 0, okay? And then look, Eric.
Yeah.
S equals 0, let's play sum equals 0. And x equals, let's do DQ, right? Q dot what? How do we DQ it? Pop what?
Left first. Always left and always next is right. Always.
Not always, it's usually, okay? Pop left, we take a Q, Eric, and then take an element which is now x, and then x plus equals what? We want to edit the sum to the s variable, so it will be x dot value, yeah? Right? Yes?
Yeah.
And then now I need to push its key to back to the Q, yeah? If x dot left, what should we do? And if x dot right, what should we do? Can you tell me?
Q dot.
Q dot what? We push
Need to append it.
append x dot
Something.
left, x dot left, yeah?
Yeah.
And then what
then
is
Q dot then X dot right.
We're done. Yeah, we're pushing its key back to the Q.
And what's the time complexity?
Not yet. Now we have this sum, right? Right? We have this sum, yeah?
If S is small.
Now we have this sum. So after this for loop, we know that S is the current sum of the current level. So we need to do this. If S bigger than, we also need to add another variable called max sum, okay? Max sum.
Wait.
And then max level, okay? Max sum, max level, okay? And then initialize to minus infinity, okay? This variable. How do you initialize to minus infinity? You do this float. Float INF, converting the INF infinity, okay? Look, INF means infinity. Convert it to float, negative. So look, if S is bigger than max sum, alright? If x equals bigger than s sum, then
What?
max sum equals x, right?
Yeah.
And then we need to record the level at this time. Max
Yeah.
level equals level. Okay, we forgot the level thing. Look, the level here will be level plus equals 1, yeah? Because every time you're doing operation, you're increasing the one level, am I right? Yeah? And return, let's return. What are we returning? Return
Max.
max what?
V.
level, max level. We are returning level.
There isn't any V here.
Yeah, does it make sense?
I want a sample back to the O-N!
What's the n?
Where we need the number of notes!
The number of nodes. What's the space complexity?
O-N! O-N!
Why is O-n?
Because where's that?
Because
Q.
what? Q. We are using the Q, right?
Yeah!
Okay, look, because look, there are lots of variables we are introducing, right? Look at this max sum, max level, right? And then we need to check if it's bigger than max sum, then we update the max sum equals x and remember the max level at this time, right? Does it make sense?
Yeah.
Okay, now we can also remove this and then use let's just record it in the data, yeah? And every time every time we don't check this if, we just put the data, put it in the dictionary, yeah, level, yeah, because this level is increasing from 0 to 1 to 2 and equals s, right? So now,
Next one is the
so
same.
after return this, so after this we have a dictionary which has the key as the
.com.
level and then value as the sum, right?
Yeah.
Now then, how do we return? If the maximum, the key of the dictionary when the value is the maximum? For example, look, Eric, like dictionary, yeah, using this, yeah?
.com.
Like this p. Let's say p.
.com.
Look at p equals Eric. Let's see,
Me.
Eric equals A.
We.
Okay.
I'm 8.
Ryan
Equals 7.
equals 7. Okay, and then how do we return the key of the item which has the maximum value? You get my point? First of all, you need to
Yeah.
get the value. This is key.
Yeah.
This is value. Which value has the biggest? Is the biggest.
Me.
8. Yeah. Well, and I want to return the key. Yeah. Does it make sense? Does it make sense?
Yeah.
So how are we doing this?
Sorting it. Yeah.
Yeah, we can sort it. We can do this. Look, we can first of all get the value. V
Let
equals
me get one.
max key dot values. Yeah. Now you need the values. Yeah. You know the value which is 8, and then you can just do this for I in P, and then if Pi equals this V, then return I. Yeah. Does it make sense? Does it make sense?
Mm.
Does it make sense? First of all, we get the value, which is A, maximum, and then we iterate the keys with Eric and Ryan, and we check which value is equals to A, and return the I, which is the key. Alright? We can do it using lambda, which is simpler. Lambda, you know, the one-time function. So we can do this max. Look, this is one line. Look, P dot items. And then how are we checking the maximum? We can use this lambda x column x return the key which is 1. X0 is the key, x1 is the value, right? And then after this will return the item which is Eric and A. And which I want the Eric, and then I put a 0 here. Yeah, Eric? This is a bit fancy syntax. Do you see it, Eric? Yeah? Yeah? Does it make sense? This is the lambda function. Lambda is like a short function, which is take x and then return. Eric, x is the pair. It's a key value pair, and I want to get the maximum based on the value here, right? And when I get the maximum pair, which is Eric and A, and now I want to return the key, which is 0, which is Eric. Okay? So why I'm talking about this is previously breakfast search we store the level and sum into a pair, into a dictionary data, right? This is level, and then this is the sum. Eric, am I right? Dictionary key value, right? And after this, I can just use this. Max return data.items lambda x1 0, and then you will return the key, which is the level. Am I right? Yeah. Yeah? Does it make sense?
Yeah.
Okay.
Yeah.
So breakfast search, okay? So can you tell everybody like what have you learned so far? Just one or two sentences. Yeah? It's your turn. Begin your show, please. Can you all, using this, can you just tell everybody what have you learned so far? You don't need to write a code, you just explain what have you learned so far. Okay?
Okay.
You can write a binary tree and then, okay?
Okay. So
Write it properly, not drawing it.
a binary tree.
Yeah. That's a very gigantic root. Huge root.
Oh, okay. I'll put in.
Yeah. Hurry up.
Okay, I'll say for I. Actually, I just add a
Tomorrow
one.
is the same but
I'll
breakfast
just
search.
9.
Yeah.
And it's still ON.
Yes. Well
And
done.
it's still ON for space complexity as well.
You want to have Durga to explain?
Okay, so the first line 0. Next line 1. Next line 2.
So that's the level, okay? Level, yeah, and?
And this first line.
Explain it like, explain to a 3-year-old boy, okay? Come on.
So.
Explain to Didi, okay?
This is a binary
I'm not
tree.
3 years
Yeah,
old.
okay.
And
The second level, you want to...
the first level equals to 15. The next level equals
13.
13. And
The sum.
The sum, and it's 10.
And we want to return what?
The largest.
The largest,
Which is
the
the
level which has the largest sum, right?
Yeah.
Which is 15, but we want to know its 0 level, okay?
Yeah.
So what algorithm are we using?
Breakfast
What's breakfast search?
level by level.
Okay. And what kind of data structure are we using? What's queue? First in
First out.
in Python, how are we creating a queue in Python?
We are
You know the both ends, what's that?
double-ended DQ.
DQ, yeah, DQ. And then at the beginning we need to initialize the queue with which node? With each node. At the beginning, how are we initialize the queue?
We're initializing the queue with DQ.
No, I mean which node has to be put in the queue first?
Root.
Root, okay, that's it. Okay, that's it for today. Thank you. Say see you tomorrow. Okay. What are you what are you drawing?
A pineapple.
A pineapple. Okay, that's good. Pineapple, it looks like a turtle to me. Turtle is on fire. Look, this is the head of turtle. This is the back. Okay, that's it. See you tomorrow.
Bye.